Okay guys, so here's a quick little review over graphing, in case you were not here or you didn't get the notes. So the first thing we talked about was with graphing, there's always an independent variable and a dependent variable. The independent variable is the one that you choose for the experiment. An example of this would be like, let's say that you were trying to figure out how high a ball bounced versus how high it was dropped from. Well, the thing that you're choosing is how high it's dropped from, so that would be your independent variable, and then the height that you drop it from would be the would determine basically the height it bounces to. So the height dropped would be determining the bounce height. Time is really an exception, because with time, any time that you use time, it is most likely going to be the independent variable. The reason for this is, even though you can pick the intervals of time, really time moves on its own. So any occasion where you're using time, it's the independent variable, because it really doesn't depend on anything. It's sometimes a little deceptive, but just trust me, if you're using time, make it the independent variable unless I say otherwise. The dependent variable, the independent variable will go on the x-axis. The dependent variable is the variable that is dependent on the independent variable. Example, the distance a car travels is dependent on the time that it's moving. So you can't have a car go any distance unless it's traveled for a period of time. So the time is the independent variable on the x-axis, and the distance would be the dependent variable on the y-axis. So those are your two variables. The next graphing is interpolate and extrapolate. So interpolate is to find new data points within the data you collected by looking at the graph or a pattern, and extrapolate is to find new data points outside the data you collected by looking at the graph or a pattern. So I wrote these formulas here as well, because they're going to help us to interpolate and extrapolate. The first is the formula for a line. And I'll just rewrite this a little bigger because I couldn't figure out how to get it to be bigger. Y is equal to mx plus b, where y is what is on the dependent axis or the y-axis. So whatever variable is the dependent variable, or whatever variable is on the y-axis, goes into that spot. M is the slope, and x is the variable that's the independent variable on the x-axis. So whatever is on the x-axis goes in that spot. B is the slope-intercept. Most of the time for us that'll be 0, so you really won't have to worry with it all that much. The formula for slope is m, for whatever reason. M is what slope is. So this is the formula for slope here. And just to write it a little bigger, you've got m is equal to y2 minus y1 over x2 minus x1. And these are 2 points, so you're just going to pick 2 points on your graph and use those. So you'll grab x1 y1 point and x2 y2 point, and those will be the points you use. Okay, so these two things really help us to interpolate and extrapolate from graphs, which is going to bring us to the last thing here. So I've got a little chart where we maybe went and collected data in a lab. All right, and so, this might be a car, I don't know what it is, but there was something that was moving for 4 seconds, and it went a total distance of 21 meters, and I've got the distances listed that we measured it at those times. Okay, so how do you make a graph? First thing, and the thing that's wrong with this already, is that I did not label what unit goes with time and distance. So I'm going to make seconds go with time and meters go with distance. Okay, so now we know that this is in seconds and this is in meters. All right, the next thing I need to do is I need to label my graph. So I'm going to put up here distance versus time. Technically I think it's supposed to go y versus x for whatever reason. When you label it, I don't really care, just put one variable versus the other variable and it'll be fine. The next thing we need to do is label the axes. So the axes are going to be labeled by figuring out which is the independent and dependent. So if you'll remember, I told you that time is almost always the independent variable, so I'm going to go ahead and put this on the x-axis and go ahead and put what unit it has by it. Distance is the dependent variable, so I'm going to go ahead and put that on the y-axis. So we're going to label this distance, and again put the unit that it's measured in. So we've got time in seconds and distance in meters. Now the thing that usually gets a lot of people is they want to make the intervals the same. So you'll notice that time's going up by 1 and distance looks like it's going up by about 5. So you can't, it wouldn't make sense really to put time 1, 2, 3, 4 and then distance 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Alright, you don't have to do that. You could, but you don't have to. So what you can do is you just need to make sure you're consistent within the axis. So for example, with time, I am going to put intervals here. So we are going to have, I'm going to make some intervals, and I'm going to label these 1, 2, 3, and 4. But for distance, which is going to be the same thing, except I'm going to put the same intervals, same steps, right? I've got a ruler here and I'm going by an inch. Okay, so I'm doing the same thing here, but instead of going by ones, I'm going to go by 5s. So I'm going to do 5, 10, 15, 20. Okay. Now, obviously here, let's see, if we kept going up, this would go to 25. So just to give you a quick little example here, I could keep going up, and I could get it to go a little bit higher, and if I went just a little bit higher, it would go to 25. Okay, and if I went a little bit farther out here, it would go to 5 seconds. All right, that's outside my graph, but we'll see in a second why that's important. Okay, so now we're going to label the points. So again, you do not have to have the same units or the same amount on both sides. On the y-axis, I went by 5s. On the x-axis, I went by 1s. So we're always going to see if we can get a 0, 0 point in. That's always nice, because if you have a 0, 0 point, it's an easy spot to find on your graph. Next up, we've got our 1, and at 1, it's at 5. So I'm going to mark that at 5. At 2, it's at 9. So I'm going to find 2, and I am going to find 10. I'm going to go just a little bit below it, so that it's at 9. Okay. Then we're going to go to 3, which is at 15. So at 3, I'm going to go up to 15. Okay, so 3 we're at 15, and then 4 we're at 21. So I'm going to go just a little bit beyond 20. 1, 2, 4. Okay, now that looks like a pretty straight line. So let's see what happens if we just connect it to the dots here. So if we just connect the dots, okay, let me do this. Let me get a ruler out so you can see what I'm talking about. If we just connect the dots, we got some slight variations. Okay, so it looks pretty straight, but you'll notice there's some slight changes in where it goes. So it's not a perfectly straight line all the way through, because they're not all the way straight. Right here is kind of an obvious example. It kind of goes in one way and then out another way. It's a very small angle, but it is an angle. So this isn't what we use. What we use is called a best fit line. So we're going to use what's called a best fit line. And the line of best fit is just a straight line that goes through the points, but it doesn't have to hit all the points. So what we're going to try to do is we're going to try to get it to go through the points, and it may or may not hit all of them. But it's a straight line that approximates the slope. Okay, so this is our best fit line. Now, let's try this again one more time. Sorry about that. Okay, let's do this one more time. There we go. Okay, so you'll notice that I hit most all the points, but I've got this one off a little bit, and that's fine. That'll happen. My 3 isn't perfectly on there, and the reason is this isn't a perfect graph. Like, you're not going to be drawing a perfect graph. That's the reason we go for best fit lines. Now, when we go back to interpolating and extrapolating, that's basically trying to figure out information within the graph. So, for example, we didn't get a measurement for 1.5 seconds. But now with this data, I can look at 1.5 seconds. I can find it like right there, roughly. And I can go up on the graph and see where that hits. And you should be able to tell it's about halfway in between 10 and 5, which is about 7.5. But if we wanted to be really accurate, we could use our formulas that I showed you a second ago. So if we're using our formulas, we can actually get a better approximation. So I'm like erasing this real quick. So our formula was using the slope formula. So y is equal to mx plus b. This is 0 because that intercepts the y-axis at 0 right here. The y is going to be our distance. The slope is going to be a number. And then x is going to be time, because that is what's on the x-axis, and distance is what's on the y-axis. So that's the reason it goes in for y. So let's find the slope real quick. I'm going to do this over here in the corner. The slope is equal to y2 minus y1 over x2 minus x1. So we're just going to pick 2 points that hit this line pretty well. So I'm just going to use 0, 0, and I'm going to use 1 and 5. Okay, those 2 points hit the line. You really wouldn't want to use this point because it's off the line. Okay, so whenever you're doing it, don't use points that are off the line, but you can use points that are on it. So if we do this, we get y is equal, or m is equal to 5 minus 0 over 1 minus 0, and you would get 5, and then look at what is on top. So meters are on top and seconds are on bottom. So this is 5 meters per second. So over here, I'm going to fill that in, 5 meters per second. So d is now equal to 5, and then we can plug in whatever number we want to. If we wanted to plug in 1.5, we could plug in 1.5 and you get 7.5. But you could also extrapolate, get it outside the graph, and we could do d is equal to 5, and then let's say we went to 5 seconds, and you could find that it was at 25 meters. Okay, so like this would be an interpolation, and this would be an extrapolation. All right, so that was the basics on graphing.